This particular web video is going to be dealing with the topic of vectors and scalars. Now, most of you have been using vectors and scalars for a little while now. This is just a refresher on how to deal with them mathematically and making sure that you're doing the right things while trying to solve problems that include vectors and scalars. We'll talk a little bit about adding things in one dimension. Then we'll move on to finding the magnitude of addition of vectors in 2 dimensions, and then we'll move on to some trig stuff. So if your teacher hasn't gone over trig, you don't have to find angles or anything like that. Don't worry about the second half of this video, but the beginning stuff will give you some good tips and pointers, just some things to remember while you're working the problems. Okay. For this presentation, it's good to remember to take notes on your own. Have a piece of paper in front of you. When I give you time to answer questions, pause the video, work out the problems on your own, and then watch my solution. Now, it doesn't really do you much good just to sit and watch me do these problems. Working the problems on your own and then watching me do the problems and drawing any attention to the problems that you may be having trouble with on your own will give you a good idea of what to study before a test or quiz. Make sure that you write down anything that I talk about that you didn't previously know or that maybe you've forgotten, because again, these are the kinds of things that are good study guides. When you're working the problems, make sure that you draw a picture. Vectors were invented as a way of graphically describing many of the phenomena in our physical world. If you're not drawing a picture, you're not fully understanding, fully working with all the tools at your disposal. Make sure you label that picture with the quantities that are given to you in the problem. It's a good way to write this stuff down so that you don't do something wrong, adding, subtracting, that kind of stuff. Anything that you can, put it down on paper. It seems tedious at first, but it'll save your butt when you're working through the problems on the test. Solve the problems. Then, after you've solved the problem, go ahead and watch my solution. And again, note anything that you didn't do that maybe I did, or anything that you caught me saying that you've forgotten about. So, what is a vector? You should know these 2 things. They're 2 important parts of what vectors are and how we use them. Take a second to write down the 2 important parts of a vector and give me a couple of examples. One of the things that you should have written down: all vectors have a magnitude. How much of the quantity do we have? So say that you're walking 2 meters to the left. 2 meters is the magnitude. How much? How far? How fast? Okay? How hard did you push? Those kinds of things. 10 miles per hour forward. The 10 miles per hour is the magnitude. The second thing that's important with a vector is the direction. Okay? If there's no direction included, then that's a problem. One of the things that we use vectors for, again, like I said, is describing motion in the physical world. So the example that I wrote down, 10 newtons backward, backward being the direction, 4 meters per second up, up being the direction. Okay. When we're doing this graphically, we'll need to draw the direction using an arrow. Okay. The arrow will always have a point on one end, a tail on the other end. We'll call this the point, or the tip, and this the tail. The magnitude we usually describe with some form of lettering. I really recommend that you write down the units along with the value of the vector itself. If we just talked about vectors, the next important thing to talk about is a scalar. How does a scalar, the mathematical quantity, not somebody who's climbing a mountain, how does a scalar differ from a vector? Go ahead, pause the video, write down your definition of a scalar. A scalar is any quantity that is not direction dependent. Okay? So, they just have a magnitude. No direction is involved. One of the prime examples that we use for scalars is mass. It doesn't matter whether you're moving forward, backward, jumping up, jumping down, your mass will stay constant. Okay? So, what I'd like you to do is make a list of all the scalars that you've talked about in class and all the vectors that you've talked about in class. Go ahead and pause the video and then start it up again once you've made a list of several different quantities. As I said before, mass is one of the prime examples of a scalar quantity. On the other hand, weight, which is the force of gravity pulling on your mass, is going to be a vector, since it is a force. Okay? In my class we've talked about this before, but this little arrow guy right here, okay, this guy right here, drawn over the top of any variable. Remember, f of g is a variable, the force of gravity, and m is a variable. Both of these are what we would use in the equations to figure that out. When an arrow is included over the top, it means that we're talking about a vector, not just the magnitude, but the magnitude and the direction. Okay. For all weights, it's always going to point towards the middle of the body that is creating the gravity. In the case of weight, force will always point into the center of Earth. Another prime example of scalar is distance. When you're asking how far somebody has gone, you don't care which direction they've moved in, you just want to know how long they've walked or how long they've driven, those kinds of things. On the other hand, displacement. Distance is a scalar, displacement is a vector. Notice that I've included the arrow over the top of the D just to show the difference between the two when we're talking about variables. If somebody were to ask you how far is somebody from where they started, they're asking you about displacement, because you could have walked forward and then backward, and the distance that you've covered will be different than your displacement. We're actually going to do a problem like that a little later on. Speed is a scalar, and conversely, velocity is its vector quantity. Notice again that I've included an arrow over the top. In my class we use v for both speed and velocity, and we use the arrow to describe which one's which. Velocity is important in almost everything that we're going to talk about from now on. We won't talk about speed very much as we get on into the more complicated topics, because velocity tends to be more of the important topic. Okay. Acceleration, also a vector quantity. There's no acceleration scalar, but there is just the magnitude of acceleration, which is usually the variable a without the arrow over the top. Same thing goes for forces. Forces will just, if you just want the magnitude, it'll be an F with no arrow over the top. Okay, so when adding vectors in one dimension, if both vectors are going the same direction, then they both need to have the same sign. Doesn't matter what that sign is, it can be positive or negative, but they need to be the same. So I have vector A, I'm going to call it plus 9 meters, so then that means that if the vector B, since it's going the same direction, needs to also be positive. Notice that it's shorter, so it's got a magnitude that's smaller as well, 4 meters. When I want to find the resultant magnitude, how much do I have after I've added these two together? I will just add the 9 plus the 4, and that'll tell me that it's 13 meters for the resultant magnitude. Now, if I want to find the resultant, I also need to remember to keep the sign as well. Now, if I also want to find the direction, I'm going to use the tip-to-tail method. That is when we line up the two vectors, tip of the first one to the tail of the second one. And if you have multiple vectors, 3, 4 vectors, it'll be the same thing. The third and the fourth vector, tip-to-tail, tip-to-tail, tip-to-tail. So I'll bring this guy down and this guy up. Notice that the tip is meeting the tail right here and right here. The resultant then will be drawn from the tail of the first vector to the tip of the last vector. This will be my resultant. Okay. We've got to make sure I label it and also make sure that it has the right value. Remember, we said earlier in the last slide that it would be 13 meters. Got it here, 13 meters, positive, making sure that I keep the sign. Now, when adding vectors in opposite directions, got to make sure that I give one of them positive and one of them negative. Let's stick with our convention from earlier. Let's call to the right positive 57 meters per second, and let's call to the left negative 20 meters per second. Okay. Add the two together and it'll give me the magnitude. If I have more positive than I do negative, I'm going to end up with a more positive answer. 57 plus negative 20 is going to give me something that's positive. Okay. So then actually adding them together graphically. Remember, use the tip-to-tail method. We're going to bring this guy down, bring this guy up, and they are going to have a resultant that will go from the tail of the first one, right here, to the tip of the last one, right here. That vector is going to look something like this. Okay. The magnitude, got to make sure that I label it, 37 meters. Notice that right, we said earlier, was positive, so my magnitude at the end will stay positive.